we're going to start matrix multiplication. So this is about as far as we're going to go with doing operations with our matrices. The video that we watched told us that you can't divide matrices, so we're not going to work on that at all. I can't tell you why you can't divide matrices because some mathematicians think you can and some mathematicians think you can't. We're not even going to worry about messing with any of that. We're just going to go as far as matrix multiplication. So what we're going to do today is we're going to be able to find the product of matrices, so two matrices, and then we're also going to apply matrix multiplication in real-world settings. So let's go ahead and move on to our first question. So here we have a question that says, find AB or A times B if A equals that matrix and B equals that matrix. Here's what you need to know, your first step for matrix multiplication. You need to check the dimensions of each of your matrices. So what that means is that the columns of the first one need to match the rows of the second. By first one, I mean the one that comes first when you're saying A times B. If I said B times A, it would be different. So we're going to go A times B. So A is my first one. B is my second one. So I need to make sure that the columns of my A matrix match the rows of my B matrix. So two columns here. Columns go up and down. Rows go side to side. So two columns here, two rows here. So we're good to go. We can go ahead and multiply these matrices. And if you need some help whenever you're writing out the dimensions, you could also make sure that this number is equal to that number. So your N of your first matrix is equal to the M of your second matrix. So here's how we do this. It's going to be quite different than adding and subtracting matrices. When we added and subtracted, we matched up our different elements, and then we just added and subtracted from there. This is going to be a little bit different. What you're going to do is you're going to take your first matrix, and we're going to make a little box over here for our first matrix. Now what we're going to do is we're going to take our second matrix, which is B. So A times B, A is first, B is second. And we're going to put B on top. You okay?
Yeah. So when multiplying, it can be uneven.
Like the matrices. So the only thing that needs to be the same about your matrices is that the columns of your first matrix match the rows of your second matrix. So the dimensions, when we did adding and subtracting, the dimensions had to be exactly the same. In this one, they just have to be, the rows just have to match the columns. So columns first and then rows second. Okay, that's for you, and there is yours. Okay. All right, so now what we've done is we have matrix A over here and matrix B over here. And he kind of did this in the video that we watched. So what we're going to do, and I'm just going to draw these lines because I can't make them look really well whenever I'm doing it with the smartboard, so we're just going to draw the lines. We're going to make a type of table. So you go underneath the first row of your elements on this side and just draw all the way across like this in between these ones. And then the same idea for your top part. So I'll just go in between these. And that tells me that my matrix is going to have the matrix, my answer matrix, will have this many columns, two columns, and then this many rows. So I can go ahead and I'm going to make my answer matrix be in green. Now I can go through and we can talk about how to actually multiply the matrices. What you do first when you multiply matrices is we're going to match up our elements again. What we're going to do is we're going to take this element here in your first matrix, upper left hand, going to match it up with this one. Notice that those are also in the same little table area, so in those lines, those are the ones that are there. So we're going to match those up first, and we're going to do all of our operations with these two and these two. What you do first is you take the outside and the top and the left, you multiply those together. So 5 times negative 4, negative 20. Now you go to the bottom one and then the far right one, and you match those up. 3 and negative 1. 3 times negative 1 is negative 3. Now I have two numbers. I have to somehow do something with them that will get me this one number. So the next part we do is we add these. So negative 20 plus negative 3 is negative 23. So I do all of my operations within those lines of my table. If it helps you to draw the table, if it helps you to cover up maybe what you're working on, which one you're working on, you could also do that. I kind of like the table idea because it tells me, all right, I need to go this way, and then I need to go this way, and then add them together. So we'll do the next part. I'm going to do the same idea. Go over to this part. I'm going to go over to this side of my B matrix. Matches up with this line. So this side, still going in the top part because I'm going above my line and then to the right of my line. Negative 2 times negative 4 is 8. 3 times 3 is 9. Add those numbers together and I get 17. We'll move on to the next one. So going now to this row right here. So second row, first column. 2 times 5 is 10. Negative 2 times negative 1 is 2. 10 plus 2 is 12. Still, second row, second column. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. So I'm going to get negative 10 over here. And then the last one, or the last row, first column. 1 times 5 is 5. Negative 1 times 7 is negative 7. So negative 2 here. And then negative 2 times 1 is negative 2 plus 7 times 3, which is 21. So we'll get 19 over here. So matrix multiplication is a little bit more complicated than adding and subtracting. You can't just go through and say, I'm going to do negative 4 times 5 and get a number, and 3 times negative 2 and get a number, and just keep doing it that way. We have to go piece by piece. So we're going to start here. We're going to multiply those together. Start here, multiply those together, and then add them. And your table can help you figure out which elements you're putting together. So whichever ones are in the same part of the table will tell you which elements to put together, which ones to multiply, and then how to add those as well.
So on the last one,
Did I do it wrong?
well, I don't know. I got 7.
Okay, so what'd you do?
I did 7 times negative 2 to get 14, and then 7 times 3 in
Okay, so we go full row, full column. So you take this top one and you multiply it by this. So right here, see how, let's go back to this first one that I did right here. So first row, first column, this, your left, so the left-hand one goes with the upper one right here. This one goes with this. And then you continue that throughout. So if I go down to this row, if I go down to this row, to the second row, 5 matches up with 2, negative 1 matches up with negative 2, and then going down to this last row, negative 2 matches up with 1, and 3 matches up with 7. So think about, see how I do these lines right here that kind of tells you which part goes with which. So your top row of this matrix right here will go with your left side of this matrix here, and your bottom row will go with the right side. So just think about it like a path, like if you were just drawing a path from one to the other. So you multiply the ones on the path and then add them together. Make sense? I'm going to tell you right now, I cannot explain to you guys why we do matrix multiplication this way. When we do, we're going to do some word problems, and it'll probably make a little bit more sense when we actually do word problems so you can see an application of why this makes sense. But I cannot actually explain to you why mathematicians discovered that it works this way. but this is how we multiply matrices. So it's a little bit more complicated, but we'll do a lot of practice with it, so don't get too intimidated by it at first. So does anyone have any questions before I continue on? So we're going to do a few more practice problems, so don't worry. All right, so here's one that's a little less complicated. Let's look at this one. Raise your hand if you think that I can multiply those matrices together. All right, Sarah, why do you think I can multiply those matrices together?
Because there's 2 columns in the first one and 2 rows in the second.
Correct. So we can see that their number of columns matches the number of rows. You could also say that they're both square matrices as well. So just noticing your columns line up with your rows. So we're going to have the same idea. First one, they're both the same. They're equal matrices as well. Second one. And we can go ahead and draw our line. Now the same idea as the last one, the only difference is now I have a 2 by 2 instead of a 2 by 3. So in this box right here, I will get 3 times 3 plus 2 times negative 1. So 3 times 3 is 9 plus negative 2, so I would get 7. So that one would be 7. On this part, negative 1 matches up with 3, so negative 1 times 3, 4 times negative 1. Add those together. So negative 3 plus negative 4 is negative 7. Then this last one, match up the 3 with your 2. So 3 times 2 plus 2 times 4. 6 plus 8, 14. And then in this last one, negative 1 times 2 plus 4 times 4, 16, plus negative 2, which is just 14. So I know when you guys are writing this, it might get a little bit messy whenever you're trying to multiply your matrices. So whatever way you want to do it, if you want to write out what you're multiplying in your matrix first and then write your final matrix, you can do that. You could do what I was doing before where I did everything on the side and then I just filled it in. You could do whatever you need to make it make sense to you as you're doing your work. I have the luxury of being able to erase and rewrite things constantly on here without it causing an issue. So does anyone have any questions about that one? Okay. If you don't have a sheet of paper out, go ahead and get a sheet of paper out. I want you guys to do this one. Bring it back. If you aren't finished, that's okay. We're going to go ahead and do each step together. So, Kindle Hart. Hold on one second. Alright, we're going to go ahead and go over it. So if you're still talking or still working on it, go ahead and pause and turn to the front so we can go over every step. And I'm going to call on someone to do every step. So make sure you're paying attention so you know where we're at. Alright, Kendall, what is my first step that I would do?
Let's multiply 2 times 2.
So I want to multiply 2 times 2. We'll get 4. Then what do I do after that, Kendall?
Multiply 3 times
0.
0.
And then I do what?
Negative 3 times 2. Negative 2.
So I multiply 2 times 2, which gets me 4. 3 times 0, which gets me 0. Negative 2 times negative 3, which gets me 6. Add all those numbers together and we get 10. Okay? So, sweet Brennan. Next step. If I want to go to this element right here,
Okay.
what would I do? How would I get that one?
We would multiply negative 4. Multiply 1.
And then we'll all those numbers together, and I'll get negative 16. Everyone good so far? All right. Carson, you want to help me do the next one? So I want to go to this element right here. So first column, second row, this one right here. What would I do first?
Multiply
2 by 1. Then,
and 3 by 4.
and then
Negative 2 by negative 2. You get 18.
you got 18. I'll put 18 right there. All right, Sydney, for this element right here, what would I do? Negative 2 times 1. I'll put it down here since I forgot to erase. Then what? And then negative 8. Add all those together, so negative 6. All right, Tiffany, want to do this one?
Multiply negative 1 by 2.
So negative 2,
And then 3 by 3.
9.
And multiply 1 by negative 2.
So then what do I do with all those numbers?
Add them together.
Add them together, and I get 5. Okay, and then I have one more. So, Reed, do you want to do this last one?
Negative 2 and negative 1.
Negative 2 and negative 1. 1 and 3. And then I add all those together, and I will get 9. Does everyone feel okay with that one? Everyone do okay with that? Anyone have any questions about that one? Okay. Let's look at this last one. Make it go higher for you guys. So this last one. Raise your hand if you think I can multiply those matrices together. Raise your hand if you think I can't multiply those matrices together. All right, good job. We're all on the same page. Just double checking. So making sure that the columns of the first matrix, I have 3 there, match the rows of my second matrix. Well, I have 3 columns and I have 2 rows, so those don't match, so I can't multiply those matrices together. Always the first step, because I don't want you guys to draw everything out, try to multiply them, and then discover that you can't and have done all that work. Okay. So now we're going to move on to word problems. I think we're pretty good so far with multiplying matrices, just doing the solid numbers right now. So let's think about matrices, multiplying matrices in a real-world scenario. So in this scenario, we have a family who wants to get a condo for a vacation. This table over here, I don't know why they tell us about this family, because the question that they ask has nothing to do with the family, so we're just going to focus on the table. This table right here, these rows are different complex names. So we have Sunhaven, Surfside, and Seabreeze. And then the columns tell us how many of each type of room they have. So at Sunhaven, I have 36 2-bedroom complexes, 24 3-bedroom, and 22 4-bedroom. So I want you guys to go ahead and make a matrix of the information in this table. So on your sheet of paper, write down a matrix of this information. And then I'm just going to go ahead and fill mine in because I think the majority of us would have done it this way. Could I have swapped those around? Could I have made my rows my columns and my columns my rows? Yep. So just like always, we can always swap those around. Now, in this question that we have right here, tells us how much each of these rooms rents for. So every condominium has the same prices for what they rent their rooms for. So they tell the family that they could rent a 2-bedroom condominium for $1,796, a 3-bedroom for $2,165, or a 4-bedroom for $2,538. Here's the next part that I want you guys to do. I want you to make a matrix of the prices that they quote. So using that 1,796, 2,165, and 2,538. So I think the majority of your guys' matrices will look like this. If not, this is what we're going to aim for them to look like, because we are going to want to multiply those matrices together. That's what we're going to do at the end here. And if we go ahead and match up, right here is our 2-bedroom. Well, that goes with the price of the 2-bedroom if I were to draw that path. 3-bedroom goes with 3-bedroom, 4-bedroom goes with 4-bedroom. So now I want you guys to multiply these matrices. Go through and just multiply those matrices right now, and then we'll talk about what you guys just found. So, 2 matrices. This is my first one. This is my second one. 3 columns here, 3 rows here. I can multiply those. So go ahead and go through and figure out what your resulting matrix would be. How to do that, and then we can work through the next 2 together. So remember, we want to go through and we want to take this number, top element, multiply it by the side element. So you want to go top element, multiply it by the furthest side element, second element, middle element, third element, or bottom element by the right hand element, and add all of those together. So I think what some of you guys were doing, from what I was noticing, is we were taking this number and we were multiplying it by this, and this. So you're taking the top number and you're multiplying it by this one, and by this one, and then adding all of those together. The only difference about this one is just that our matrices look a little bit different than what we were doing before. Still the same idea, matching up your rows with your columns. So row 1, column 1, row 2, column 2, row 3, column 3. Multiplying those all together. If it helps you to also think about how $1,796 is the cost for a 2-bedroom condominium. So multiplying that by this would give me the cost for a 2-bedroom condominium if all of them were rented out. $2,165 is the cost for a 3-bedroom, and $2,538 is the cost for a 4-bedroom. So we could take these pieces apart and figure out what each of these are individually, but instead we're using a matrix and figuring them out as a whole. So now that I've told you guys this, does that change what anybody was doing on their paper, or are we all kind of on the same page now? So what would my first element be here? Oops. 174, what?
172.
Oh. So 1,796 times 36, 2165 times 24, 2538 times 22, and add all of those together. What about my next element? What will my next one be? 227,960. Does anyone disagree with that? So in that case, we're taking 1796, going down to the second row, 1796 times 29, 2165 times 32, and 2538 times 42, and then adding them all together. And then what would my last element be on this one? Anyone? 125 what?
642.
125642. Any disagreements about that one? Okay. So what we found here is we know how much it costs for each of these to be rented out. So let's imagine that all of them were rented out. Now, if I owned all 3 of these condominiums, I could see how much my complexes are making if all of those rooms were rented out for 1 week. So I would make $172,000 and then some at Sunhaven, $227,000 at Surfside, and $125,000 at Seabreeze. So that helps me know how much I would make in a week if I owned those complexes. Does anyone have any questions about that one? Okay, so we're going to do one more. We're going to do this one a little bit differently. I don't remember the last time you guys have done this. I know you guys did this at the beginning of the year, but what we're going to do is I'm going to read this problem to you. I'm going to tell you what I want you to find. Then I'm going to give everyone a sticky note, and you're going to write your answer on it. Also write down whatever else I'm asking you. And then in the back there, Brennan, you were looking back there. Did you know what I was going to say? And then back there, put it on green if you feel really confident about your answer, yellow if you're about your answer, and red if you don't feel real great about your answer. And then tomorrow when you come back, I'll show you guys what it actually was for what you guys put back there. Everyone understand? Okay, so in this problem, we're told that the average family spends this much money on school supplies, about $500. So mom has 2 kids, Barbara and Lance need some school supplies. So they make a matrix. They call this first matrix M. So that first matrix M, Barbara puts down how many pens she wants, how many pencils she wants, how many erasers she wants, and Lance does the same. Now they want to figure out how much money they're going to spend. So they go over here and they figure out how much a pen costs at store 1 and at store 2. And they call this matrix P. What I want you guys to do is I want you to compute or find MP, M times P. After you've found M times P, I want you to tell me what it means. So notice which one comes first, which one comes second. Make sure you're multiplying those matrices. And then I'll go ahead and pass out sticky notes. And if you don't have enough room to also write what it means on the front, you can write it on the back. And then whenever you're done, you can go stick it in the back. And I will look at them later and see how you guys did. And then we can talk about this one tomorrow before we do EOI prep. So you guys can go ahead and work on that.